Hello and welcome back to compiler programming. What I want to do today is to deal with sequences of things when parsing. And when I say sequences of things, it can be arguments, it can be statements. Basically, when you have stuff like this and you have a separator, and then you want to apply some action to each of the elements of this sequence. Right now, there is a sort of an ad hoc solution that I've put in for the arguments, but it's not very robust and it will not work long term. Also, we'll need to do something for statements. So if we have, like, for example, two things that we want to do, stuff like that, we also can't do that right now, and it's not gonna survive us for long. So before I introduce any new tests, I will start working on the new implementation, and we just want to keep all the current tests working. So let's run them before we do any changes and verify that everything is fine. Okay, now let's start the change. Here's what I want to do. Right now we have this token mature state, and basically I want to change so that we don't pass the token here, but rather we pass directly a list of tokens. So we say array token pointer, and we say tokens. And then I also not big fan anymore of this child index name. I guess the better way to say this would be start index. And now we can just replace a bunch of stuff in the file to make it not complain to us about this new stuff. So a bunch of child index stuff. Yep. And it also will complain about dot root. So this is also what we want to fix. For the expression thing, we actually should pass in the state instead of passing in the token directly. So we say that this is not going to be a required thing anymore, I guess, and instead what I want to do here is say token mature state, and here it will be state children. We don't need this stuff anymore. This is fine. We don't need this stuff anymore either. So that's fine. Let's just build and see what kind of errors we get, and we just fix them one by one. State children, yeah, it's gonna be called tokens, I guess. Yeah. So state tokens, state tokens, state tokens. More of this stuff. Okay, that's good. Here we now just say tokens is args tokens, or here it's args children actually. Okay. Here it's the same thing. Tokens is parent children. And the same thing here, where we say tokens is token children. Okay, what do we have here? Well, this is a token pick. We can just change this to be state tokens. Okay. And what do we have here? Yeah, I guess here is where we do match expression, and now it doesn't accept a token. Instead, it accepts a token mature state. So let's give that to the function token mature state. Star state is ampersand, or actually, let's do it like this. And here we would say tokens is body children. And then we just need to do it like this. Okay, that sounds good. Let's see if that works. That's good. We can add this to git index and continue. So this change wasn't just an arbitrary one, but the idea is that now we can create a helper function that would return to us basically it'll take a sequence, split it on the token that we want to provide, and return it back to us. So let's start writing that. That would be called something like array token mature state, which we actually need to define. So type def dynamic array type of token mature state, array token mature state. Okay, this is what we're going to return, and it will be like token split or token array split. Doesn't matter. We pass in an array of token pointers, so tokens, and we pass in the pattern token like we do here. So we probably will need to split out this procedure as well. Let's see a bit later. The idea here is pretty straightforward. We take that state, we create it, right? And then we iterate over tokens. Is less than the array length of tokens. Okay, we return a result. And this is what we do here. So we take tokens our source token. This will be a dynamic array get of tokens I. And yeah, this thing needs to change slightly. So I guess I will extract it into a separate function and say token match token star source token star pattern token. Actually, both of these can be const just to be nice. We can take this stuff and say if it is not true, we return false. If this is not true, we return false. Can also probably shorten this up a bit, since both of them are talking about tokens. What else can it be? Just it's a bit nicer to read. There is no need to be so verbose. Yep. Like that. So now we can do if not, or if token match of source token and pattern token, and then return source token, otherwise we return 0. Or maybe it is better to do it other way around to keep with a filter approach. So like this. That seems good. Pattern, yeah, this needs to be renamed as well. Okay. So now that we have a way just to match the token by pattern, we can use this here and say if token match source token pattern token. We do something, otherwise we do something else. So we also need to have like an array that is going to be used in the mature state. So array token pointer star, let's call it sequence or something. Dynamic array, make array token pointer. And actually this is what happens here as well at some point. So we go through the list, right? If we find a match for the separator, maybe that's would be better better name here. So we say this is a separator, and this is just a token. Yeah, I think that's better name. If we're matching the separator, then we just create a new intermediary array, and we put the old one into an result. So the dynamic array push of results token mature state. It will get the sequence, so tokens is sequence, and then it's gonna be 0. So that's fine. Otherwise, we basically push the current token into the sequence, like so. And finally, at the end, we need to push in anything that remains here as well, because especially like if we don't have any tokens, or this is basically the remainder after the last separator. Yeah, that's not correct. It should be like this. That's good. This also should be like this. And here we need to have a star. Okay, so we can run test, but we didn't really change anything, so that's all should be fine. Though at least we didn't break this stuff, which is good. Now, we actually are ready to start using this split. And the way we're gonna use this split is there is not gonna be this stuff anymore here, so we are not gonna try to match it on comma. Instead, this is gonna be part of the splitter there, and that means we basically expect to consume the whole sequence here, and that means that we need to introduce something new here, and I guess call it something like token match end, and we assert that what is it? Pick index is state dynamic array length of state tokens. Yep, that looks good to me. And that means we can remove this stuff, we can remove this stuff, we can remove all this. This is fine. Now everything is broken though, because we need to replace this part over here. And what's gonna happen here now is a bit different. So we say array token mature state. argument states, and it will be token split of args children, and we need to have a pattern. That pattern is going to be source slice literal comma. Oops, wrong button there. And then we say that the type is token type operator. Okay, so we take in all the arguments just to show you what I'm trying to do. We have these arguments here, right? We take all of them, we split them on a comma, and we end up with these parts separately as separate states. Then we should pass each of them to our thing that deals actually with arguments, and we are ready to continue. So we just say that like this. Actually, we need a loop 0 I is less than argument states. Okay, we get the argument, or first we get the state. The measure state is get from these states the ith element, and this is what we pass here. Now previously we had this if here, which wasn't actually very good because you could not consume the whole input. But now, since we first of all assert that we match the whole sequence inside of token match argument, we also need to always assert that we actually get something back from token match argument. And that means that we can say assert arg. Obviously later on it will be an error, but for now we just do an assertion, which is fine. And what all is left is do the actual definition of stuff that we have over here. So if I haven't messed up anywhere, then this should be fine. Children is not a thing, yes. And now everything is great. Let's try to run this and see if this was fine. Great, so it all worked with first try, which is quite surprising to be honest, but it's also very, very nice. Cool. This holds it up now, I think is rather nice because we can do cool things. So in next step, I think what I will try to do is I will try to support. So we have here one argument, and I will try to maybe do the following. I will do plus, and it will be x that is s32 and y that is s32, right? And it will return x plus y as it did before, or it's the plus should return, let's say that way. And here we'll just say plus 40 and 2. So currently this is not something we can deal with, but this is something we can do. And actually now we can change the type. Okay, I'll run test. I'll show that it explodes, as you can see. And where it explodes is over here, where it says we actually do not support matching codes with multiple arguments. But now we can. We need to do a couple of things for that. So we need token match expression. Yeah, so I guess I have to like do a forward declaration for this over here because we'll need to call it, right? Because we need to like try to here we just do token force value, but this is not correct because you can have like I could totally do this stuff, right? This is perfectly fine, or I can do even stuff like this is also perfectly valid argument. So every argument that we pass to a function, it's also an expression in itself. That means that we need to call token match expression here and not token forced value like we were doing before. So that's just something to do. Where is our lazy function? I can take this stuff out, basically, even with a check. That sounds good to me. And this is what we are gonna be dealing with now. So we have, if the, I guess we will need to have an array of token stuff, actually array of value, array value pointer star args, star just, let's call it result, yeah. Dynamic array make of array value pointer. So if there are some children, then we split it on comma, same as before. And we don't need this stuff over here. Instead of token match argument, we say value star value. And here we just do token match expression. We will need to pass in state. Yeah, we need to pass in scope and we need to pass in the builder. Okay, and we push in result value. Something along the following lines. Okay, let's see if I have done it correctly. See how it goes. Look at that. We now have multiple arguments. And as said, we can also do stuff like this. So that should be perfectly fine. Let's try that. Sorry, test. Actually, apparently not. So what is not implemented now? Actually, this should be, I guess, 30 plus 10, so that we end up with the right number at the end. Okay, but what don't you like? It's line 541, and it has no idea what to do with, yeah, okay. That's also pretty easy to fix. And basically, it doesn't know what to do with just parenthesized expression, but it's actually very easy what to do with parenthesized expression. You just, call recursively match expression on it. So that's very easy. We need something like this. Actually, let's first copy this part. If we have token type parents, then we expect it to be, this stuff. So state, like this. We do not have a builder when we do token force value. That is a bit unfortunate, but I guess we'll need to have one. So here it goes, and then we will figure out where to get it. Okay, so this thing is gonna be something different. it is gonna be just tokens is token children. Do we have a forward definition for token force value? Okay, and here we have the builder, so that's not an issue. Obviously, here we also have a builder, and here as well. It's fine. List different from definition. I don't have. Token P, token manage, token split. Where is the force value one? Token type. It's called parent. Declared formal parameter list different from definition. Defines it. It's a bit confusing, but okay. Let me try to find it, this stuff. So we have mass, star h, token force value. It's on line 96 of this thing. Okay. Oh, yeah, this is gonna be a bit of an issue, I guess, but we have to deal with it. Say function builder star builder. And the problem is going to be that we now need to pass in the builder here. Yeah. Here it's fine. Yeah, we have a bunch of tests actually. All these tests are this is not good. This is not good. Let me think how best to deal with this stuff. So on one hand, when we need to turn the expression into a value, we need a builder. On the other hand, we don't always have one. Especially a bit like if we need to have this builder for just getting a function out of the program, that's not really great, because at this point we don't even have one. If we just pass null here, because we technically didn't need it in those cases anyway, so maybe that's actually okay. Okay, let's see if that explodes. Did not find an acceptable encoding. Add R8 M8. Yeah, okay. This is a separate problem altogether, which is something I can actually fix relatively easily. So let's do that. So this is relating to change I did in the last video, where we now have these immediates are sized to the smallest one possible. So that's something we need to just take into account. R6, M6, so we need this version. Okay, well, let's add this version. Where is our add? Okay, this is all about 16. And we have 0, 2, which is R8 and RM16. R8, RM8, and then there is also another one, which is RM or M8. I guess let's just add it to like this. So we have our M8 immediate 8, right? It is this one, which is 80. So we can do that. And my guess is this one is 82. Or this one doesn't even make sense. Does it exist though? So it is RM and immediate 8 on the other side. This is this thing. Yeah, this one actually doesn't make sense. So it's like this. Okay. Let's see if that works. And it does indeed. Okay, that's not very elegant with the null being passed here, but on the other hand, it's also kind of okay. So here we just do assert builder. Because when we do this function definition, the builder will be just part of that function. So it will be created there. And here we basically already have one. So we can even maybe do this, but maybe not. Let's just keep it as it is. Okay, this is very good progress. I'm pretty happy with this stuff. So now we have multiple arguments. We can even try to go like really bananas and do this stuff. Let's see if that works. And it does not. So that's interesting. What is the number then? Let me open our debugger and see what's going on. So that would be in function spec. Let's verify that we are actually doing the right executable. Here we are. Where is this plus plus? Yeah, I need to save it to some variable. So I say something like S32 result is this. Okay. Good. Now we can pause over here and see what we are getting, and then try to figure out why we're getting that. So the result is really something wild, and that is very interesting. So I guess now we're gonna stop this, go here, and step inside of this function and see what is going on. Yeah, that's fine. Damn it. Need to explicitly switch to disassembly view, I guess. So go here, and now go inside. Okay. I'm not sure what is happening. So we are over here. Wow, this is really messed up. This function call is broken beyond comprehension. So before we continue, I think it's a problem with our newly added instructions. At least I think so. Just this is 02/R R8 RM8. So that seems fine. And then 80, yeah. This is not correct. So maybe I accidentally got this one as well. So it's /0. RM8, immediate 8. Actually, these ones are also wrong. They all should be of code 0. Is 83 even correct? No, it isn't. This is also of code 0. Okay, 3 is here. Yes, 3 is /R, so that's fine. Okay, I guess. We're still getting really weird result. And it has nothing to do really with what we are trying to do right now, so I'll maybe debug it for another couple of minutes, and if I don't understand what's going on, then it will be a separate topic, but I'll try to look into it a bit. So yeah. Disassembler is really confused, and I'm not sure why, because we are jumping to this stuff. There's a bunch of zeros here, which is fine. Oh, I guess it is pretty unhappy with the, yeah, so 83. With trying to add trying to add this number, which is also a very strange number. To say the least. So with what is happening, I believe. So this one actually is perfectly fine instruction. Rex W plus stuff. I'm not sure to be honest. I think I will leave this for later. This is not, this doesn't seem to be a problem with the parsing per se, but rather with the instruction output. So this is, can be tackled separately. For now, I will get back to this version of this. And this is the version I'm happy with. But before we go any further or wrap up this episode, I want to try to make this stuff work, where I would say, I can close this out for now, where I would just do a plus that doesn't do anything, but just to have multiple statements in the function. And obviously this also will not work because we weren't able to reduce the body of the function to nothing. But now I can take this stuff and we will be here. Okay. If body type value, blah, 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 that's good. Otherwise, we're gonna do this operation and we say value star last result is void value or something like this. Yeah, okay, that's fine. We have body children. What do we match body against? We actually don't. Okay, body children. And then this is body statements. They are going to be separated by semicolon. We get the state, and then we match it with expression. Yep, function scope and builder. And here we can actually do 0 and say body result. And if body result, we do this stuff. Okay, what else is wrong? Token and delayed identifier. It's not token. It is body children. And here we don't need to push anything. We just say that body result is token match expression. So basically this will be the return value of the last statement. And if it is not 0, then we do stuff. We try to return that. Okay. Let's run the test and everything is fine. Cool. I think I will debug this weird problem with nested pluses offline because it's just going to be a bunch of digging through the assembly, not something really interesting. But that will be it for today. I think this is pretty good progress. We have multiple statements, we have proper calls to functions with nested expressions and so on. We have proper parsing of arguments. This is a very, very good base to start writing some actual programs in this language. That will be it for today. Thank you very much for watching and hopefully see you next time.